Once again, good morning to all. So, in today's session, we will discuss operating system examples. That means in which operating systems we are using the threads. And next, we can discuss about CPU scheduling. So, okay, right. So, coming to the operating system examples in threads. So, that means in which environments or in which platforms we are using the threads. So, actually, popularly we are using basically three kinds of operating systems or three platforms. So, those are Windows and Linux and then Mac. So, out of these, in today's session, we can discuss where we are using the threads. So, popularly in Windows and Unix or Linux. So now we observe how we are using or implementing the threads in the Windows platform and then Unix platform. So coming to the first one, Windows threads. That means how we are going to create or how to use threads in the Windows platform. At the same way, what are the procedure to use threads in the Windows platform. Okay, right. So actually, thread concept was implemented in Windows platform from Windows 98. So operating system version starts from Windows 98. Already in previous sessions we was discussed them. So what are the different variations or different generations of Windows platform? So we start the discussion from Windows 97 onwards, 97, 98. After that Windows Network, and then 2000. After that XP. These all things, and then Vista 7, 10. These all things. Okay, in this. So this Windows threads concept threads was starts the using from Windows 98 onwards. So to implement threads in any platform, already we was discussed in thread libraries. So why we are using the thread libraries means to providing some environment. So by using such environment, here developers can easily develop their required threads. So for that purpose, we are using the thread library. So that means here thread library was providing the some environment for easily providing the threads. So such environment is known as the API, application programming interface. So with the help of this API, so Windows platform threads was introduced from Windows 98 onwards. So 98, NT, 2000 and XP and 7, 8, 10. So these are all versions. So here in Windows platform to implementing the thread. So already we discussed what are the different models of the threads. That is many to one, many to many, one to one. So out of these, so in Windows platform we are using the one to one mapping. So one to one thread. So in this. This particular one-to-one mapping thread can be used in both user mode and then kernel mode. So here each thread, so while we are going to implementing the threads in Windows platform, at that situation each and every thread contains several things, several contents. Those are so thread ID. So first of all it contains the thread ID. Why we are using thread ID? So to identify some specific thread among several threads. So to choose or to complete any process, so which thread is suitable or which thread is access or perform the particular process. So for that purpose, to easily identifying some specific thread among several threads. So for that purpose, here each and every thread was identified with some specific ID. So with the help of this ID, we can easily recognize. So and so ID, so and so thread is processing the some process one. So and so thread is processing the some process two. So for that purpose, for such kind of information, we are using the thread ID. And next, it was also contain some register set. So already at the beginning of the thread concept, we was discussed them. So whenever we are using the thread to perform the some execution. So for that purpose, it was using the some register set. So some set of registers to perform the such execution. So that's why while we are using the threads, so that particular thread can contains the set of registers. So this set of registers can be used to perform the process or execution of the any specific process. So for that purpose it was using the some register set. So this register set contains some number of registers to execute the instructions. At the same way, while we are going to thread, creating a thread in Windows environment, so it can maintain separate stacks. So here stack means nothing but some memory. So here, while we are creating the thread, so such a thread can maintain separate stacks for user and kernel. So here, why we are using separate stacks for user and kernel means to store user related data or user mode data. So for that purpose it was using the user stack. To store kernel mode related data, for that purpose it was using the kernel stack. So in this, so two modes can have the separate stack memories for storing their related data. In addition to these two stacks, so while we are going to using the threads, it was also maintains local data, so that is some private data. So this private data storage area was used by runtime libraries. So while it was going to executing something at that situation, so the private data storage area can be used by the that particular thread. So for which purpose it was using such a private area means to accessing or to providing the some dynamic information or some dynamic libraries information. So for that purpose it was using the private data storage. So already in last session was observed, so thread storage, so it was actually static data, static memory only. So that means it can, once it was store some information, it can't able to change that particular value in that particular memory location. So for that purpose we are using this some private data storage for dynamically linking the some specific libraries or some data. So for that purpose we are using the DLL, dynamic linking libraries. And here each thread contains some register set. So in addition to that, each and every thread can maintain the some stack memory and private storage area. These all combination can be treated as some context of the thread. So here context of a thread means nothing but whatever the register set was used by that particular thread, and whatever the stack memory was used, and private storage area memory was used, and these all combinations can be treated as some context of a some thread. Next, so here the primary data structure. So what are the primary data structure for the thread? So now we observe some basic or the minimum requirements for the thread data structure. So here these threads was basically categorized or classified into three categories. One is the E thread, and another one is the K thread, and another one is the TEB. So these are the three environments or three data structures was used by the threads. So coming to the first one, E thread. So here E thread indicates executive thread block. So E thread indicates executive thread block. So that is also represented as ETB. ETB. E indicates executive, T indicates thread, and B indicates the block, ETB. So this executive thread block was used to including the pointer. So to include the pointer to processing to which thread belongs to the K thread. So that means it was simply referencing the which pointer or which thread was using the K thread. So here K thread means nothing but kernel thread. So here E thread or executive thread block can contains which type of information, currently which thread was using the or which thread was belongs to the kernel thread. So such kind of information was provided by the E thread. And coming to the kernel thread, so that is K thread. So here kernel thread can be used for scheduling and synchronization of information. So in addition with kernel mode stack and pointer to TEB in kernel space. So for that purpose we are using the K thread. So that means so once any thread is created, then to execute such particular thread, so for that purpose it was shifted or switching to the kernel mode. So at that purpose, so here CPU can schedule that particular process or that particular thread, then only it was switching from user mode to the kernel mode. So for that purpose here CPU was scheduled, so which process can execute at current time. So after completion of that one, which process can be executed next. So for that purpose, what's here? CR, mute your mic. So here K thread can maintains which type of information means scheduling information, synchronization information, and a kernel mode stack, pointer to TEB, and kernel space. So these all information can be maintained by the kernel thread. So here scheduling means which thread can execute at which time. So at currently which thread can be executed, after execution of that one, next which thread can be executing. So such kind of information can be provided by the schedule. And next synchronization information. So to execute that specific thread, so whatever the necessary things, such all things can be provided. And a kernel mode stack, so to use the particular thread execution in kernel mode, it requires some memory. So to complete that particular thread execution in kernel mode, for that purpose it requires some memory. So such memory was provided by the kernel stack. And pointer to be TEB. So TEB indicates thread environment block. So it was referencing to the thread environment block. So this information provided by the, sorry, this kind of information, this is the responsibility or functionality of the K thread. And coming to the next one, TEB, thread environment block. So this thread environment block contains total threads information. What are the total number of threads? So those threads can be created and currently used by the which mode. So and those threads related data can be stored at which memory location. So these entire things can be maintained in the TEB. So thread environment block. So these are the three kinds of primary data structures are used in Windows threads. So now we observe this data structure in some diagrammatic representation. So here this is the E thread, and next K thread, and next TEB, thread environment block. So here executive thread block, so which is responsible for pointing to the parent processes. So it was representing or linking to currently what is the parent process. Here parent process indicates currently running process. So and K thread, so it contains it is responsible for scheduling and synchronization. So that is the major responsibility of the K thread. After that it was storing the related information into the kernel stack. So and then it was sending the reference to the thread environment block. So in this thread environment block we are contain which type of information? Thread identifier, user stack, and thread local storage. So this thread identifier indicates the it was uniquely representing or identifying that particular thread. So for that purpose here each and every thread was referenced with some ID. And user stack to store the user related data, and then thread local storage to store such entire information into the local storage. So these are the data structures among Windows thread. And next coming to the Linux threads. So now we observe how we are using the threads in or implementing the threads in Linux environment. So actually in Windows platform we are called thread. So but the same thing can be performed in Unix platform. Those things can be called as the task. So here in Linux terminology we are using the term that is the tasks. So here this task creation or thread creation. To create the thread in Unix environment or Linux environment, we are using this some system call. That system call is clone. So with the help of this clone system call, we can create the some thread in Linux environment. Here this clone system call can allow a child task. So that child task is responsible for share the address space of parent node or parent task. So that means, so initially we are creating this some parent process or some process. So that is task. So that task can use some child processes to complete their task or to complete their process. So for that purpose here it was using the some child task. So that child task can access the data from parent address space. So parent node was whatever the data it contains. So such entire information can be accessible by the child node. So here, while we are going to using this clone system call, you can have several functionalities like flag control behavior. So it was especially used in the form in the manner of flag control behavior. So here in Unix environment, to using the threads or implementing the threads, we are using these several flags. Those are clone fs, clone vm, clone signal handling, clone files. So here clone fs indicates file system, and VM indicates virtual management or memory management, and clone sig hand indicates the signal handling, and clone files indicates the whatever the operations belongs to the files, set of files. So these are the several flags are used in the Linux environment. So these are the details about threads are used in Windows and Linux platforms. And next we are going to discussing about CPU scheduling, very important concept.